Hello, in this video we're going to actually be graphing some trig functions, specifically sine and cosine. Okay, so we're going to go back to our previous knowledge that we have, which we covered last time, which was the unit circle. So this is your unit circle. You should all at this point be able to do this one. If I gave you a blank sheet with the unit circle on it, you should be able to fill them all in. Okay, so, all right, now on this one, if I were to ask you what is the sine of 30 degrees? All right, so we go here, the unit circle, here's my 30 degrees, and we're asked to find the sine of it. And the sine of 30 degrees, here we go, we have to identify what that is. Well, we know that the sine is the opposite divided by the hypotenuse. Okay, so we're going to take that information now, and we're going to start plugging some things in, right? I mean, we know that the distance between the x-axis and that point, we're looking for a specific point here. The distance between that and this point, we'll just call it B. Right? And the distance between the origin and where B meets the x-axis, we'll call that A. All right. And so our point right here will be A comma B, right? It'll be A distance, this distance, whatever this distance is, away from the origin, and it will be B, this distance, away from the x-axis. All right. So as we're looking at this one, sine we know is opposite side B divided by hypotenuse over 1. So we know that the sine of 30 is equal to B. Well, what is B? Well, B is right here. If that's an ordered pair, that's my y value. We'll get to that. Okay, so I can plug sine 30 into my calculator. Well, sine 30 spits it back that it's 1/2. So B, my y value on that point right here is 1/2. That is my y coordinate when we go to sine 30. All right, well, if I know my y-coordinate, all right, I got this. I got 2 of the sides. I had to be able to find my third side using the Pythagorean theorem. So let's do that. Okay, A, here we go. We don't know A, but we know B. B is 1/2, and C is 1. So now what we're going to do is we're just going to square it. Here we go. 1/2 squared is 1/4. 1 squared is 1. So we've got A squared plus 1/4 equals 1. And we've got to solve it, so we move that 1/4 over to the other side. That's 3/4. A squared equals 3/4. We take the square root of both sides, and we end up with A is equal to the square root of 3 divided by 2. So the coordinate is square root of 3 over 2, comma, 1/2. Now, if you've been practicing filling in your unit circle, you know that already. That sine 30, that is the point. Right there on sine 30 as you come out is the square root of 3 over 2, comma 1/2. All right. Well, and that's where it comes from. All of this is just to kind of show you where that number comes from. All right, now we've got all of these. And what we need to know about this is that sine of a given number is equal to the y value. And if sine is equal to the y value, what do you think cosine is? Cosine of this same number, 30, would be cosine is adjacent over hypotenuse. So radical 3 over 2 divided by 1, which is radical 3 over 2. So cosine is your x values in this scenario. Okay, so sine are your y values, cosine are your x values. Okay, so I could ask for anything. If I ask for sine of 135, so 135 is right here. I know that sine are my y values. My y value in this particular ordered pair is the square root of 2 over 2. There we go. If I ask for the cosine of 7 pi over 6, okay, 7 pi over 6, all I'm going to do is look at this unit circle, and I'm going to go right here to 7 pi over 6. I look right at this, and I know that cosine are all of my x values. And my x value in this case is the negative square root of 3 over 2. So that is cosine of 7 pi over 6. Okay, I want you to get some practice on this. All right, let's pull these in. So push pause on the video. If you need the unit circle, you can go back to this one. But here are the ones that I would like you to look at. Okay, cosine of 300, and I'd like you to look at the sine of 7 pi over 3. Okay, push pause on the video now. After you've obtained the answer, come back and push play. Okay, let's look at this. Hopefully you got these. Now remember that the sine is all of your y values, and cosine are all of your x values. Should be pretty easy if you can fill out that unit circle. This part is just a breeze. It's nice. Okay, I want you to try these two. Push pause on the video now. After you've obtained your answers, come back and push play. Okay, check your answers here. How did you do? Hopefully you're getting that a little bit, getting just a little bit more practice on those. Okay, now I'd like to graph what the graph of sine of x looks like. And to do this, we're going to bring in our unit circle again. Okay, this gets just a little bit crazy, but just bear with me just a second here. Okay, if we were to start at 0, and then we could go in, and then sine would be 1/2 when cosine my y values are radical 3 over 2. Radical 3 over 2, oh man, can you try to find that on the graph for me? That is a little bit of a nightmare. So I'm just going to push pause on that for a second, okay? I'm just going to kind of skip to the big points. Okay, the big point here is 90. At 90, my sine value is 1. I'm going to put a little dot there. At 90, it's 1. Okay, and I'm going to keep going around this unit circle here. At 180, my sine value is 0, right? That's my y value. So my sine of 180 is 0. So I'm going to put it right here. At 180, I'm at 0. That would mean at 270, as I keep going around this circle. Okay, I'm going around this circle, and when I come up to 270, I find out that my y value in this case is -1. And then when I hit 0, when I come all the way back, right, I've done the whole circle and I come all the way back to 0, my sine value on that, and again, that's your y value, is 0 again. Okay, and then it kind of starts over, right? So now what I have to do is just kind of draw a line to connect all these, and it's a curvy line, okay? So it curves around, right? It goes up and it curves down. It goes up and curves down. And it continues. That's why I put the arrows on it. So that would be my graph of the sine of x. All right, well, if that's the sine of x, and it continues, what's the cosine of x? Well, that's kind of the same thing, right? We're just going to use the same process. The only difference is here, let's see, if I'm at 0, it should be 1. Right, so I'm going to start there. If I'm at 90 degrees, or in this case pi half, then it will be at 0. Then if I keep going around over here at pi, I would be at -1. At 3 pi halves, I would be again back at 0. And then at 360, or in this case 2 pi, at 2 pi I'd be back again at 1. So now I connect all of those. And I kind of have that same pattern. They start and they stop at different points, but the pattern looks fairly similar. I mean, if this cosine continued, it would keep going up and down like this. Okay? All right, so if we've got that down, we got those two. What about sine of x -1? Okay, and that looks a little bit weird, but you're going, I know what the sine of x is. So all you have to do now is subtract 1 from every one of those, right? This one would go down 1. This one would go down 1. Instead of it being at 1, it would be now at 0. This one, instead of being at 0, would now be at -1, right? The whole thing just moves down 1 unit. That's it. We take whatever the sine of x was, and we move the whole thing down 1 unit. That's it. Okay, cosine of x, well, what is 2 cosine of x? So we figure out what cosine of x is and multiply that by 2. So instead of it being 1 here to start, we're going to start up here at 2. And at pi halves, 2 times 0, oh, that's still 0, okay? And then at pi, 2 times -1 is -2. So it's going to be a little more dramatic, right? That's our, that's going to create a longer graph. This is very similar to what we did with quadratics. With quadratics, when it was in vertex form, that changed how quickly it grew. This is the same thing here. Okay, so we know these two. Here's what I'd like you to find. Okay, pause the video now. I'd like you to go in and try to work out these two problems and graph them. Okay, let's look at these two. This one is 1/2, so we take whatever cosine of x was and just multiply that by 1/2. So instead of going all the way to 1, we only go to 1/2. It's a much milder, if you will, graph. This one, I threw you just a little curveball. I want to see if you could get it. All right, and on this one, what it basically is we take the sine of x, and then as it says here, we multiply it by 3, and then we add 1. Okay, that sounds a little bit weird, but we just go right here. The sine of x at 0 was 0, so that's the same thing. Sine of x is 0 times 3 is 0 plus 1. Boom, we start right there at 1. Okay, when it's at 90 degrees, sine of x is at 1. So we go 1 times 3 is 3, plus 1 is 4. Boom, it goes right to 4. And then we just continue that around. Okay, it's just more of an amplitude. The whole graph is shifted up 1 unit, and it grew by 3 units, okay? Or 3 times, I should say. All right, hopefully this was of value to you. I'll put some other videos together as well that put for very specific problems.